This video covers operating systems and core concepts, including batch OS, symmetric multiprocessing, SMP, I/O structures, and OS services. A batch operating system executes jobs in batches, one job at a time, with no user interaction. The CPU can be idle during I/O operations. The multi-batch operating system supports multiprogramming by holding multiple jobs in memory. The CPU switches jobs during I/O, leading to better utilization. Comparing the two, batch OS processes a single job with low CPU usage, while multi-batch OS handles multiple jobs with high CPU usage. In the batch OS, the process flow is from user to batch, then to disk, OS, and finally the CPU, with jobs executed sequentially. The multi-batch OS diagram shows multiple jobs in memory, and the CPU actively switches between these jobs. Symmetric multiprocessing, or SMP, involves multiple CPUs that share memory and run a single OS. It is considered a tightly coupled architecture. Clustered systems consist of multiple nodes, each with separate memory and OS. These nodes are connected via a network and are considered loosely coupled. SMP uses shared memory but has limited scalability. In contrast, clusters use distributed memory and offer high availability. The SMP diagram illustrates multiple CPUs accessing shared memory before performing I/O operations. The cluster diagram shows multiple nodes connected via a local area network, or LAN, to shared storage. The I/O structure includes I/O devices, device controllers, and the I/O subsystem, all managed by the operating system. I/O components include devices like a keyboard, disk, and printer. Controllers manage these devices, and the OS handles system interrupts. The storage structure is categorized into primary storage, secondary storage, and the overall storage hierarchy. Primary storage consists of fast and volatile components like registers, cache, and random access memory, or RAM. Secondary storage, such as hard disk drives, HDD, and solid-state drives, SSD, is non-volatile and offers a large capacity. Operating system services encompass program execution, I/O operations, file management, and communication. Program execution involves loading the program, allocating necessary memory, executing the process, and finally terminating it. I/O and file services handle reading and writing to devices, creating and deleting files, and managing directories. The OS facilitates communication through inter-process communication, or IPC mechanisms, along with error detection and fault handling. Resource allocation includes key responsibilities such as CPU scheduling, memory allocation, and device sharing. Thank you for watching this video on operating systems and core concepts. This concludes the video.